So today's webinar is going to be conducted by Engineer Kithmal Perera. Engineer Kithmal Perera is the Managing Director of Lotus Construction and Management Consultants Private Limited. He has 15 years of industry experience in construction management and consulting for high-rise buildings in Sri Lanka. He has worked on numerous projects such as the Colombo Lotus Tower, Avic Astoria, Colombo City Centre, Homelands Mixed Development Projects, and Trizon Residencies Development Projects, and several more. So I can assure you today you are in excellent hands. I invite you to engage with our speaker and ask your questions. So you may ask your questions in the chat and we will address them towards the end of the session. Keep an eye on the chat as we will be updating you on when the form for the certificates is open. So if you look at the video description, the link to the form is there, but you are currently not able to access it. So please do make sure that you keep an eye on the chat because we will send a message when the link is open. And you need to fill that form if you are to receive your certificate. So make sure you do it on time. Make sure your name is written correctly, as there will not be any changes later. Please do keep an eye on that. So without any further delay, I now invite Engineer Kithmal Perera to take over this session.
Thank you, Aisha. So good afternoon to all of you. So good afternoon to all. So today today's topic will be a challenging in the construction challenges in the construction of high-rise building. So mainly what I'm planning to talk about, these are the contents. Most of the high-rise building involve in different type of foundation works, and also that excavation and retaining system. Structural work, basically concrete, reinforcement, and the form, different type of form works, and also that when considering the high-rise building, there are the layout changing in the different levels. So then the main concept is introducing the transfer flows. So I will talk about the transfer flows and also scaffolding system. And the main axial shortening and measuring, because different towers you are different axial shortening depend on the heights and the concrete property. Waterproofing methods and facade installation and the survey methodologies. Those are the main basic areas I am planning to talk today. So, and also this presentation based on the case study. So that I have involved in the Astoria resident project. So this is a multi-development project, including commercial and the residential and office. So project is located in DR Vijayawardhana, DR RA Mel Mawatha Colombo 3 in Sri Lanka. That's normally we know as a Kolpiti. So the project description is there are 4 towers initially planned. All the 4 towers around 40 story, but finally they have slight change in the 1 tower and scope also change. So you can see tower 1 and 2 is a tower 1 and 2 is a residential building. Tower 3 and 4, tower 3 is for office building, and tower 4 is again the residential building. So normally that both tower 1 and 2 is almost 150 meters. That highest one is 148. Tower 1 is 142 meters. Tower 4 earlier design as 127. It's not changed, but Tower 3 we designed as 127 meters, but due to the scope change, it's changed to the around 87 meters. So this is a project layout. So actually this tower 1 and 2 is you can see this tower 1 and 2. These two project actually foundation already the actually contractor client acquired the land that the foundation already done. That means earlier that there's a design for another high-rise building. Therefore, all the pile foundation and the basement construction already constructed. So therefore, the challenges was to design the new two tower, convert the foundation for the tower 1 and 2 new design, and also that there were enhancement work for the foundation, and well as some strengthening work done for the existing foundation and the vertical element. Tower 3 and 4 design was done as a new design, but all 4 towers we design amalgamate to the one design in the later stage. So basically foundation system, when we consider the foundation system, when we consider the foundation system, pile foundation, normally in Sri Lanka, most of the high-rise building use pile foundation. So I'm going to talk about the piling, and but some projects like Cinnamon Life, I have involved with the Colombo Lotus Tower. Those projects we excavated it up to the bedrock. Then we will do some raft foundation on the top on the bedrock. But here we have constructed pile foundation for the tower 3 and 4, and also that, as I say, tower 1 and 2 piling was done for the previous design, so that we use same pile layout for the foundation for the tower 1 and 2. In this project, we have 4 type of piles for diameters: 800, 900, 1002, 1800. So total pile is 163. And also detailing, when you see the left hand side, so you can see all the reinforcement detailing done for the earthquake detailing code established in Sri Lanka. And also piling rock socketing, we have done normally 3 diameters of the pile. So these are the basic construction methodology for the pile construction. First, you have to do the setting out for the required location. Then we use cast institute piles. So, and also we use very good machines like BG machines, and do the setting out. Then you have to do the casing installation. After that, you have to do the soil boring and the rock boring. After that, once the pile is achieved to the required level, you have to clean the pile. So before cleaning, you have to insert the reinforcement cage, and also that using the trimmy pipes and the bentonite, you have to clean the piles. Then once the pile is properly cleaned, you can start the concreting. Concreting also using the pipes and the funnels, trimmy pipes and the funnels. So these are the basic pictures for the piling construction. So it's in detail area, but I basically touching what we have done in the Avic Astoria project. So it's a very important when you are doing the pile foundation to determine the rock level. So this is a basically we have to done with the borehole investigation. So normally we are doing the borehole investigation and identify the where the rock level, and where basically in the normal rock profile you will first you will find the weather rock, after that the hard rock. So normally the pile shocketing will start from the hard rock. So and also but different because it's why I say that's important. You can see here there are some formations in the rock, some lower points and higher points. So you can't stop the piling in a different level because some piles one pile cap having a 6 pile for the pile cap. Then that all the pile has to be terminated, should be terminated in the one level. Otherwise, it will be having a different the deep because depend on the dip angle. So rock that it will be not stable. Therefore, you have to go proper shocketing by under developing the rock profile of the piling. This is a mandatory requirement when you are doing the, especially on the high-rise building. So then the other important thing is how you're going to select the pile for the testing. This is one of the system we developed to identify the piling test piles. We are calling physiologic system, because normally if you have 160 piles, but normal requirement or standard is giving a 4% testing for the pile dynamic analysis, so load testing. Normally we are doing the integrity test for the all the piles, but for the load testing we are doing for the limited because of the cost factor. Therefore, you should have a proper method to identify what are the most doubtful piles. So this is a method what we have using for the especially for the building piling project, we call physiologic. So we have a scoring system during the construction stage. So, first of all, that we are giving scores for the depend on the machine. First column is a machine. So if the contractor use good machine, so we give a low score. If we use some old machine, it took take long time to do the boring, we give a little bit more high marks. Then the rock socketing. If the pile is penetration, rock penetration during the rock socketing, it's very high or low, but rock samples are seems to be good. Then the we are giving another marks for the depend on the rock socketing. That is a second column. And the other thing is a maintain borehole. That means how long borehole is exposed and how long it's keep it before concreting. So that is another point we are determined. Based on that, again we are giving the marks. And also cleaning. Before concreting, you have to clean the pile. So that also we are giving the marks based on the once after you we can analyze the data, bentonite data. Based on that, we can give a marks for the cleaning. And also concreting. Concreting also smoothly done, we give a low mark. If it is something happen, trim pipe may be pulled by the contractor. Likewise, we give a higher marks. That is for the construction process. After that, we, as I said, we are normally doing integrity test. This is the integrity test. This is the most important one. We are doing we are calling PIT, pile integrity test. Based on the pile integrity test, we can identify whether we have a soft toe or whether we have a soft toe. That means normally wave is going up from the bottom. We call soft toe. That means there can be a soil. Normally it should be go like uh, this down curve. If it is in the PIT if shown upward curves, it can be a soft toe. So here we depend on the piling, and also there can be a when it consider pile, there can be a we call bulging like that in the pile. Let's one side bulging. Other we call pile necking. So concreting with the neck. So that is another defect. So these things we can identify in the PIT test. So based on the, if it is a bulging, it's not a big major issue. But if it's a necking, we can increase the marks. Based on that, we will identify the total marks where final scores are given. Here, final scores are given. For the highest marks, we select as a test pile. This is a method we are normally using if we have 100 the huge number of piles. So these are the tests, as I said, pile testing. So we have to do the PIT, and also normally we are doing the maintainer load test for the test pile. But here in the Victoria, we haven't done the load MLT before the design the pile, but normally it's recommended to do the maintain load test. That will give a good understanding about what is the capacity of the pile. And also normally we are doing 4% of the piles for the PDA. PDA means pile dynamic analysis, that we are dropping the load from and analyzing the pile analyzer. So after the piling, the next major step is the excavation. So you can't normally in the high-rise building involve several basements. So that so you have to excavate more than 6 meters, or more than, sometimes you have to excavate more than 15 meters even. But here we excavate around 6 meters. You can see the height with these people. So normally around more than 6 meters we have excavated in the Astoria. Here there are several retaining system. The secant pile we use in the AVIC. So that means you are doing the two female piles. Two female pile means without reinforcement, and do with the male pile that is including the reinforcement cage. So that is a secant pile. Here you can see the secant pile wall, and also sheet piles. Sheet piles also another method. Here you can see the sheet pile driving machines, and the diaphragm wall. Diaphragm wall is another method we are using for the deep excavation, and the timber shoring. Timber shoring means using HIN and the timber planks. So you can see the excavation. So here we have a sheet piles. Here we use, because lift area you have to excavate more, and some you have to go more deeper than that. So we can't, the secant pile are highly expensive. So we use sheet pile for the lift for excavation. And also that pile hacking, excavation, and all together you can see in the last picture. So during the excavation, it's very important you have to maintain all the parameters, such like that deflection of the retaining wall. It's more important. You have to monitor the deflection of the deflection of the retaining system. So you can see retaining system, that pile hacking in here. So sometimes your test pile, you have to, before excavated, you have to cast up to the ground level. So then you have to, again, you have to hack the pile for the required level. So these are the some normal practical problems we are involving for the hacking. Then the another important in the deep excavation, so grouting. Why we need the grouting? That is the most important problem, because most clients are reluctant to do the grouting. They say if you are doing the solid retaining wall, why you need? But when you are doing the secant pile or sheet pile, it's you can't visible what happened in the underground. So there can be a construction defects. So to avoid that, to get safeguard or get a remedial action, what we can do is a grouting along the excavation perimeter. So that's why we are using, we are recommending, and we are using the grout pressure grouting along the excavation perimeter. So it will fill the voids and enhance the permeability. That means water will not come in towards to the excavation pit, and also it will strengthen in the structural retaining wall. That is, as I said, when you are doing the excavation, more important to measure the requirements, parameters, guidelines. So here we have installed the inclinometers to measure the verticality of the retaining wall. So that's why these are the most important point. If you are doing the deep excavation, you should have a proper monitoring method, because you have to see whether this, when you are doing the excavation, this deflection will start or not. So you should have a alarm line. This is the safety. So that has to be measured every day, and also water level, because water level also most important. You can't dewater near neighbor's house, because if you are draw down your water level in the neighbor, that building can be settled. So that has to be more important, and also that recharging has to be done as per the required water readings. So here, this you can see the inclinometers. Inclinometers, because basically first you insert the pipe, pipes in the pile. After that, you put some sensor into down towards the pipe and measure the how much it's deflect for the to get the idea of the verticality. So pile caps, there will be a group pile cap, single pile cap, and different shape. You can see this is a pile raft here. Pile raft here. So that it will be a near the lift core and the sump area. So depend on the available space, we can shape the pile cap as a trapezoidal way. More common is a rectangular. You can use different formwork system. Sometimes you can use directly the timber, or otherwise you can go with the block work as well. So reinforcement, I'm not going to talk much about the reinforcement, because these are more typical. But in the high-rise building, you have to use the couplers. Normally in the Chinese code, they specified if you use more than 16 millimeter, you have to use the couplers. But depend on the resources availability, in Sri Lanka, we are most commonly use 25 millimeter bars and 32 millimeter bars. So it's recommended to go with the couplers. It's very easy to handle, and also that it's minimize the wastage. conventional reinforcement work here we use, and also that if you want, you can use the prefab one. Prefab mean, for example, for the walls. Here we didn't use the prefab method, but in the Lotus Tower, whole stems we fabricated in the yard and bringing into the side and lifting through the tower crane and bend. So that's a prefab method. So conventional formwork, because there are two methods: conventional formwork or aluminium formwork or system formwork. So here we use the conventional formwork because when you are using basement, that column layout, beam layout change by floor to floor. Normally, typical floor level, it's not change the layout, but other areas always change. So it's recommend to use the conventional formwork. It's a more economical. So that's a normal method we use to do the formwork in the basement. Here, as I said, for the typical floors, normally in the high-rise buildings, we are using the aluminium or system formwork. In the Avic Astoria, is a typical apartments. So we are using the aluminium formwork for the typical apartments. For the Colombo Lotus Tower, stem. So that is same shape, same formwork, but radius and the shape will change every 5 meters. So that one we use the system formwork that with the hydraulic system. The shape is changed using the hydraulic system. Here it's a normal straightforward aluminium formwork. So these are the advantages when you call that. Normally we can maintain with this aluminium system 4 to 5 day cycle, and also that you can use 250 times same formwork. So very low wastage and environment friendly system. And also the currently most of the contractors modified the aluminium formwork depend on the small changes like that. And also you can bear high load, such as 60 kilonewton per square meters. When you are doing the designing of the formwork, it's better, you can get a higher load for this one. And also not a loudy construction, because you don't have to cut the timbers like that. Eco-friendly green material. So as I said, you can recycle it. Whatever shape, you can recycle it. And also, if you use to this one very simply, you can assemble in the site. So aluminium formwork, as I said, in the most of the high-rise building, we are doing the 5-day, 6-day cycles. Then it's again the problem will come whether this concrete is strength enough to stand alone. That's so there is a specification for to removing the formwork. So normally the vertical elements we can remove 12 hours. Soffit of the slab that you can see in here. You can see here the formwork we remove within 36 hours, but you keep the prop. But we use high strength concrete as well, but 30 you are removing from 36 hours. So so you have to have a proper mix design as well. Sorry, this actually we remove the beam, soffit of the beam in the 36 hours of the slab in the 10 days. So sorry, 10 days in the unload cases, because what you mean unload mean, so normally in the formwork, you do the concreting on this top of that, the props are there. And again, you are doing the loading on the top of that for the next slab. So that time you have to keep the formwork. If you are not loading, you can remove. If you are loading, you have to keep that. So it's important in the high-rise building. You have to use different of concrete types. Most of the cases you are using the high-performance concrete, and also high-strength concrete. Always high-strength concrete is not a high-performance concrete. When you are consider grade 55, 50 to 50, more than 50, you can consider high strength. But if come for the high performance, it should be a more than grade 80. And also that high performance concrete depend on the workability and depend on the durability as well. So here, so it's important to, when considering the material concrete, you have to more focus on the material what you are going to use. You have to do the trial mixes, because if you are using a high strength, you have to use a higher, for concrete you have to use a high standard deviation to do the proper mixing. And also as I showed in the earlier, you have to do the large concrete pours. Some pours are more than 2000 meter cube, more than 3000 cubic cubes. So then those elements you have to control the temperature, and also testing. Testing can be done, need to be done in the pouring time and the after time, after the concrete as well. So concrete, it's not a magic, but these are the basic component we are using: cement, admixture, coarse aggregate, and fine aggregates. But more important is the water. Here I didn't mention the water, but water is a more important. And also the test. These are the local testing method done for the material. Admixtures also we have to do if you are doing underground concrete, you have to need to test the alkaline content. That will alkaline is one of the major problem for the chemical reactions of the concrete. And also fine aggregates. Nowadays we are very scarcity of that river sand, so we are using alternatives such like manufactured sands and the sea sand, wash sea sand. Normally we are recommending to use the wash sea sand. So as I said, it's important to do the mix design. So you have to plan on the construction stage when you need the different type of the concrete, and also need to do the proper mix design. So here we have done several concrete mix design. So here NC denote normal concrete, SCC is a self-compacted concrete. We use OPC and PPC. OPC is a Portland cement. So PPC is a fly ash mixed one, and also that for the high performance, here we mentioned the high performance concrete. Here we use the hypocrete. Hypocrete is a polycarboxylic admixture. Normally we are using for the high flow concrete. For high flow concrete, it should be a polycarboxylic admixture, super plasticizer, but polycarboxylic. And also the water cement ratio, as I said, more important. So here grade 70, you can see in the bottom of the table, we have a very low water cement ratios. Very low water cement ratios, but normally we are using a 0.34 to it's very 0.35 to 0.4 for the grade 30, grade 40 concrete. So as I said, for the large pouring, you need to focus on the temperature. Because if pour temperature is increase, then you will form a delay grid formation can happen. And also if the temperature difference is increased more than 20 degrees, it will be a gradient of the temperature, and it can make a cracks. So these are the guidelines given in the Syria guidelines, but we also use same guidelines with the modifications. Normally in our country, we are very close to, we have a very high temperature. So we are normal, our concrete core temperature, we can go for the 75 to 80. But the temperature difference also, we are limited within the 25. So normally you have to do the concrete mock-up. So that means here you can see that picture. Here that you can see the picture, we have done the mock-up, 3 side insulated and one side is normal formwork, and we insert thermocouples here, and we measured the temperature, and also you can see when the hydration is started, the temperature will increase with the time. So these are the temperature modeling and the actual scenario, so that when the temperature is too high, you can't use a normal curing method. So you have to use the sand, or sometimes sand you can use in the ground construction. But when you do the high thick concrete in the top of the building, like a transfer flow or the transfer flow like that, you can't use the sand. So then you have to use an alternative method. I will come back in when you are considering the transfer flows. So these are the temperature. You can see the actual in the pile caps, how it's changed. So in the Abic Astoria, we use the high strength concrete, grade 70. Here also we have done several mix design and finalized. These are the final mix design. There are 2 mix design. One is a normal concrete, concrete, that you can see the slump flow of the self-compacted concrete is around close to the 660, and also water cement ratio difference is depend on the workability, 0.21, very low water cement ratio in the self-compacted concrete. And also we use the fly ash for the OPC cement, and sometime we have to use the silica fume also for the high grade concrete, but here we didn't use the silica fume. So concrete testing, as I said, it's very important. Normally we are doing the slump test and the flow test and the temperature. So temperature also it's important. You are doing the concreting, and also here we call V-funnel test. So this is for the passing ability, and so this is a viscosity. This L box test is for the passing ability. So you have some reinforcement here, and we check how the concrete flow through the reinforcement. So L box is using for the passing ability. So these are one of the concrete we use. So you can see the concrete flowing smoothly, high strength concrete and self-compacted concrete. So these are the transfer flow concrete. So you can see this is a transfer flow. So whole layout will change from that level. So then it's act as another foundation. So when you are normally in the transfer flows, we have to go for the conventional formwork because it's not economical if you go for the aluminium. But if you have a resources, you can use and much easier. But when you are involving with the higher high thick sections, it's recommended to go with the plywood formwork. Otherwise, temperature difference will have a problem. Normally, transfer floors are consist with the deep beam and the thick slabs. Beams like 2 meter, 3 meter. Slab also around 600, 800 slab. So those are the concept of the transfer floors, and also you need a proper design formwork for the transfer floors, because it's involve huge load. Because the construction load is too high, so you need a proper formwork system. Normally, we recommend to go with the bracing system, with including bracing, because normally here you can see the height of the transfer flow height between the transfer flow and the lower flow around 6 meters or close to 6 meters. So then you are doing the formwork, you need a bracing system for the formwork. Otherwise, these pipes and the system can be a slender. So that is other important. And also in the construction also you can do by the stage wise. That means normally transfer flow having such a big section like this. So normally we are doing the part concrete first. Then next part we will do the second stage. But you have to make sure all the joint has to be perfect, and also that reinforcement you have to clean. That is the one method we are doing for the transfer flow concrete. And the other thing is, as I said in the earlier, that this is the curing method we are using for the long beams, deep beams. So these are because we wrap it with the polythene, and we use entrap wear here to cure itself. We avoid water curing, and we use the thermal curing on that one. So this is another formwork system. You can see that in the high-rise building, you can't do the scaffolding formwork from the bottom to top. You can do, but it's a huge cost. So there are several methods we are using. Within this video is not running, no? So it's not running. So what we have done is we use formwork system and scaffolding system, self-lifting system. It's automatically, not automatically, that we can operate, we can lift it along the wall. So you can see here. So down bottom of that scaffolding, no scaffolding. That means you are lifting. So with the construction stage, you are lifting the formworks. So that is another economical method. Unfortunately, I can't, this video will not run in here. Then the other important thing is the axial shortening. What is the axial shortening? That is the reinforcement concrete columns and the wall shorten because of the elastic compression of the creep and shrinkage. When you are consider the concrete, there is a characteristic called creep and shrinkage. So normally if you have a large section, when you are going up, it will automatically shorten. So here in this building we have 4 towers like this, no? So 4 tower with different loading, but it's all are in the same podium level. So then depend on the loading that there can be a different shortening in the different columns. Then there can be a tracks at the podium level because of this axial shortening. So what we are doing, it's important to measure what is the axial shortening for the that high loaded columns. So normally we are doing the theoretical calculation, what to check that one. And again, after that, we have to do it. Need to practically measure what is the actual. So measuring can be done in the two way. Normal survey. Sometimes this axial shortening is very low. It's very difficult to measure. So normally we are nowadays we are using the strain gauges to measure the actual strain in the column. So that is a method we use here. And also to avoid these kind of settlement, we are using the post-pouring strip. But that means in the up to the transfer flow level, not in the transfer flow, below the transfer flow, we put a strip. We keep the strip like this, separating the towers. We concrete without this strip. 600 millimeter strip, we keep it between the two towers like this. And also keep another strip like this. It's not visible, no? That means here we keep a strip like this. After concreting, after measurements, like we are, as I said, we have to do the measurements. When the measurements are measurements are not changing, that means all the load are settled. That axial shortening has happened, and after that we can cast this. That is the method we are using. So as I said, two conventional method. One is a conventional method. We are using we fix a certain point and get the levels. That is a one method. And we have used in the Avicastoria that strain gauges, and we measure the strain in the concrete. The actually main function of the electronic strain gauge is a minor stress change of if there is any minor change, it can be can be measured through the resistivity that conductor. So that based on that we are doing the calculation of the induced strain. So these are the method we are using. Normally, first we fixing the reinforcement here. First we fixing the reinforcement. Then we take it. This is after concreting the column. So that means we take the cables out from the column. So waterproofing, I'm going to slightly talk about the waterproofing. So there are four major components: basement, rooftop, pool and landscape area, and the toilets. So you have to more focus on the basement because, as I said, we are going deep basement. You always have a big lot of issues with the waterproofing. So normally here we use the bentonite one. Otherwise, you can go for the bitumen based one. The more advantage is the bitumen one. The bentonite one is you can keep it exposed long time. Normally in the basement construction, it takes a long time. So here you can expose it and keep it long time. And the second thing is you don't need the street concrete to cover it. This bentonite, and also special treatment need to be done in the edges of the pile cap, so that otherwise it will. And also there will be a PVC water bars in the construction joint. It will avoid the differential settlement as well. So these are the roof waterproofing that very important to do in the corners. You have to have an additional layer in the always in the vertical corner. Normally lap is around 150 millimeter. Based on that, there, as you can see, there's a additional layer always applied for the corners. And also normally it's recommended to do the pond testing before the waterproofing and after the waterproofing has ready. There is any structural defect, you have to rectify. And also in the waterproofing, it's important you have to control the moisture content as well. So these are the roof construction. You can see after the normally heat insulation you have to apply to reduce the heat. These are depend on the details given in the structural drawings and other drawings. So, and also in the it's recommended to put a mesh, steel mesh, to avoid the crack of the top of the waterproofing. So normally most of the contractors and builders are doing without reinforcement. It will lead for the crack as well. And also proper drainage system you have to introduce, then it will improve the that water flow into the gullies. So balcony, we are toilets and balcony, we are normally using the cementitious waterproofing. You have, as you know that those are first you have to do the 2 layers and also 48 hours pond testing mandatory to check the any leakages. So facade insulations that also depend on the high-rise building. Normally in the high-rise building you have to do the wind tunnel test. So how to for the horizontal loading. So based on the loading, you have to design the facade. In the Avic Astoria also we have done some testing in the China. So we applied the loads and see these design aluminium sections are appropriate for the loading. So this here we have a sticky type facade. So you can see how they install this one. Sticky type means you first install the mullions and fix the glasses. So you can see first they install the mullion and do the glass. Other method is a Unitex method. That means you fabricate the panel and install. Lotus Tower flower, Unitex method. That means whole panel fabricate outside and install. Here, mullions install and put the glasses. These are the 2 methods we can see. And also, highly recommend to use the structural sealant for the structural weather sealant for the outside, and also you have to do the pressure testing. Normally recommended pressure test is 2.5 bar at 300 millimeter distance. You have to apply the water pressure. So this is the system we use. We put the pipe and we pressure the water and see whether any penetrations through the window panels. And also you need different equipment. This is a man hoist here, and also there's the counterweight system. Those are the more important. So you have to plan according to them. In high-rise building, you need different methods to do the survey. Normal methodology you can't use. Normally in the survey we are using GPS method and also travel survey you have to maintain, because your control point cannot be changed. You always working with the control point. Sometimes most of the control points are not within the site, outside, because when you are going high-rise building, you can't see the close point. You have to go see the outside point. So in Avic Astoria, we had a few points outside the premises, and also Lotus Tower, we had some points 1 kilometer away from the tower. So then it's very appropriate details we can get. And also that after the 600, 100 meters above structures, you cannot do normal survey, because the structure is subject to the thermal deformations. That means in the daytime, if you get the point here, daytime, so you put the laser here, but the building is moving like that. So you can't get the exact point. So normally in the high-rise building, survey is done in the early morning to reduce the thermal deformation. And the Lotus Tower, we did the survey at the 3 a.m. Normally to do the, because you have to check the whether structure is the perfectly concrete. We start the survey in the early 2 o'clock and finish 6 o'clock. So that is the normal methods we are using. And also we did the research. That means we put the laser from bottom. So this kind of laser machine we put here. Laser machine put, and we check in the 130 meters in the Lotus Tower. So like that small plate is put in, and we get the every half an hour point. So that points is like this. It's not in the same. That means that tower is moving. Same scenario happened with this kind of high-rise building. So this is the conclusion of the today presentation in the high-rise building constructions. So basement construction will take a long time. So it take time and cost. So now, so it's advisable if you can go for the mezzanine floor parking likewise, but depend on the land value. Sometimes you have to go for the basement, but it take a long time of the project, and also a lot of disturbance, interruptions, all are encountered, and it's very difficult to handle the groundwater. And also when you are finalizing the concrete, it's important to finalize the mix design, and also do proper testing and also temperature modeling. Nowadays, you can use the computer-based modeling like MIDAS modeling or otherwise you have to do the practical mock-up. Aluminium formwork, it's important to design for the wind tunnel test or otherwise there can be issues in the water penetrations, and the glass can be break due to the excessive loading. And also that, as I said, the quality weather sealant and structural sealant should be used for the facade for the durability. And also that, as I said, the verticality is more important in the high-rise building, because in the few projects, we had a problem with the lift installation. Normally we are doing the tolerance within the 50 millimeters. So if when you are doing the constructing more than 150 meter building, if the lift core change 100 millimeter or 150 millimeters, it's very difficult to install the design lift. So it happened, I think, in the Altea dialogue building also same thing happened here. So that's important to measure the verticality of the building. So thank you very much for the today presentation. I can answer the any questions if you have.
Thank you, Mr. Kithmal. There are several questions that have been sent from the participants. The first one is, what does S and M denote when scoring on the fuzzy logic used for pile testing?
So shall we do that? M is moderate. S is we call that M is moderate. S is used for that same. Here we use same, that with no major issue. M is a moderate issues, that mean we give the 5 marks for the M, for the S we give the 0 marks.
Okay. The next question is, a score is given for pile integrity, but fuzzy logic is not used to select, but fuzzy logic is used to select a test file. Is pile selection not necessary to do the pile integrity test?
I didn't get it.
So integrity,
Yeah,
or there's the pile integrity, you have to do the pile integrity test for that?
yeah, we have to do that one.
So that is done separate to
Yeah,
this?
separated. Normally, first you will do the fuzzy score at the construction stage, and after the integrity test. Because as I said, integrity, some pile we are our cutoff levels is well below in the ground level. So then there are practical issues. But anyway, if the integrity of the pile is not good, that means we have to do the testing. Automatically, if you put the integrity value here, that pile this is a sample of the table. So if the integrity, that means, as I said, the toe is a soft. That means you have to put a high marks for the integrity. So here in this column, so we take the values for the before the PIT. The test file will select after the PIT. Understood? So that means here this is not the completed one, but normally we use a PIT value as well to select the test file.
The next question is, if we come across necking of a pile, do we reject the pile, or what is the next procedure?
It's depend. Normally what we are doing is we are doing the testing. If the pile can get the load, we will accept the pile. So if a huge neck, we are asking them to do the testing. But if the load can be that can be used, but normally so the defects quantification cannot be done using the integrity. They will give the indication. So there can be other durability issues such as corrosions like that. But here that normally we are doing the testing. We are proposing to do the PDA test for the necking stages.
What is the procedure to ensure that the pile toe is well cleaned before casting the pile?
One parameter is the testing of the bentonite, and also you have to use a manual peg, steel peg, and putting into the borehole and you can feel it. So those are with the experience you can feel it. So normally you can feel that that steel peg go and hit in the rock. If it is sand, you can see you can feel that one with the peg. So this is the method we are using in the pile.
In the case of monitoring the deflection of the retaining wall system, we need the tilt meter, biaxial inclinometer, piezometer, strain gauge, etc. Is there any company who we can contact to get those services?
There are so many well-known companies in Sri Lanka. So, file test, they are doing the file test. Yes, they are doing the testing.
Next one is, in the basement slab and pile cap construction, how do you tackle peak hydration temperature issue?
As I said, you have to do the proper mix design. And also that temperature controlling has to be done using cold water. If still it's exceeding required level, you have to use the cool water pipes. I think we have used one in the Havelock City. So that is the extreme level. Otherwise, you have to design the mix design and also use the cool water, and also sometimes you have to cool the force aggregate. That is a massive weight, the biggest weight coming from the force aggregate. So if you can put ice on top of that, that's also fine. We have done same thing in the Lotus Tower. What we have done is we cover with the ice in the force aggregate. That's the one method.
Okay. The next question about the water cement ratios. Actually, Mr. Kithmal shared the slide with the ratios just after this question. So I think that should answer that. Can you elaborate the difference between high strength concrete and high performance concrete?
The high performance concrete is depend on the workability. There are different parameters, so you can classify. For example, high performance concrete can be a self-compacted concrete, high durable concrete, or high strength concrete. High strength means more than grade 50. But for the high strength, if it is a high performance concrete, you have to the grade should be more than grade 80. Understood or not? Grade 80. So that means very high strength. But normally we are saying for the high strength is more than grade 50. But all the high strength concrete are not the high performance concrete. That is the theory.
What is your experience in the usage of M-sand for concrete?
So we have used currently also we are using M-sand. So especially when you are doing the mass concrete, it will give the bleeding and also that high cohesiveness for the wall elements. But you can do a lot of, we have done a lot of research on that one, and we work with different admixtures. For example, for the high bleeding, you can use viscosity modifier superplasticizer, VMS we call. For the manufacturer sand, you better to find proper manufacturer sand, not the corridors, because normally market available in the corridors. So it's highly recommended to use the manufacturer sand with proper management.
In case of casting massive volumes of concrete, what is the procedure for preparation of test cubes for cube test for either 14 days or 28 days?
Normally we are doing for the 1 set for the 50 meter cubes. So normally we are doing the 7 days and the 28 days. No need to do the 14 days, depend on the requirements, but normally we are using normal procedures.
When we cast the transfer flow, first stage is cast up to the slab bottom level, and can the balance be done the next day? Is there any chance of forming coal joints?
No, you have to treat that one. So normally we use the bonding agent and proper preparation of the joint. But it's very difficult because you are doing the construction stage-wise for the formwork design, because you can't get the load together for the whole load, and also to expedite the construction. So that means if you have a transfer flow slab normally involved with the shear links and like that, so it's very difficult to construct So it's easy to, if you divide it into two phase, it's more easy for construction.
What is the concrete sampling criteria or the frequency you used in this for testing?
That's what I said. Same.
What is the strain gauge action? How do we measure the shortening by using a strain gauge?
Can share that slide. Yeah. So here, what we are doing is we calculate the stress changes, and then based on that we calculate the induced strain. That is the theory we are using to calculate the axial shortening.
How did you tackle the issue in order to minimize axial shortening effects on the cladding on the facade and partitions and finishes of the building?
As I said, that post-pouring strip we are introducing. So once the settlement is completed, we cast the post-pouring and we go for the facade. That is the normal method. So axial shortening, normally you are not, if there's a considerable amount, so no point of doing the facade. It's better to keep it until that stable stage.
With regards to waterproofing, won't bentonite get affected by rain?
It can, but it can expose, as I say.
In a rooftop, how did you arrange the expansion and contraction joints?
Rooftop, normally we are not providing the expansion joint for the roof slab because it will not advisable. But you have to keep the expansion joint for the screen concrete. Otherwise, it can be a crack.
Is there any benefit of post-tension structures in high-rise buildings?
Definitely, yes. Because you can reduce the reinforcement, you can reduce the height because you can reduce the beam height. So floor-to-floor height can reduce. Then height cost reduction when you compare with the post-tension.
Are there any other questions?
So one thing is we can do the grouting. So we do the two cores. If we identified the one pile is defect or soft toe, we are doing depend on the pile diameter. So if you think this is a pile, this pile is like this, having a sand here. So what we are doing is we do the one core here. One core here and one core here. You can identify. So then after that you pressure from the water and it will clean and water, all sand will go other side, other hole. After that we'll grout it. And also that some designers, especially in the Chinese designers, they are not doing the long socketing. What they are doing, if they have a fractured rock, what they are doing is they keep the steel pipe. We call sonic log. They are recommended for the sonic logging. That is another testing to check the integrity of the pipe. So what they are doing is they put a steel pipe and they grouting this fracture and strengthening them. That is the method. That kind of design done in the new building complex at the National Hospital. So they grout the pile top. Every pile they grout it because that area rock is very fractured. So that is another. If you have a soil also same, you can clean and do the grouting. And again you have to retest. That has to be done.
There's another question. If the lift core is moved slightly or the void is not in the proper dimensions, how do we address the issue? What is the permissible allowance for lift core distances?
It's depend on the height. In the code say 3 meter. I can't exactly remember but it's a Euro code. It's given for the allowable permissible limit, and also if the normally if the lift core we from the beginning, we will give what is the tolerance we can give, depend on the building height. If it is exceed in the construction, no more option. We have to reduce the lift size. That is the problem. So we had done in the dialogue, Siata, we had a sound problem. We reduced the lift core. That is not a high rise, but it's still we reduced that.
How is the lift core wall thickness changed with the height of the building?
It's normally not because all the vertical loads, the horizontal load is getting for the shear that core. Normally we are not changing, but for a lotus tower, if you go, the wall thickness change, but core is not changed.
Creep movement prevails at least 2 years. Is there any effect on cladding?
Very rare. So for my experience, still not because we are normally. I haven't experience on that, but very rare that.
How about shrinkage movement effect on cladding?
That also that it's not because we are getting the precautions for normally creep and the shrinkage directly involved in the axial shortening. So you have to properly handle that. So if you handle it properly and you install the facade after that, there's no problems.
When thick transfer flow concrete was found to exceed the peak recommended temperature or temperature gradient, what are the options?
If it is transfer flow, it's okay because we can see, we can observe if there are any cracks separate. But in the foundation, you can't see. So that is a major problem. So one of the example is a Southern Highway pile cap. So one pile cap is suddenly exposed for some reason that all the raising cracks are there. So the foundation is the main, the transfer flow we can visible and we can rectify those things.
Any other questions?
Is the making process of manufacturing sand?
So that means there's a special crush machines. So in manufacture sand, you have irregular shapes. That crushed sand is a different that not a proper quality maintaining of that sand. The sleeves and everything are different. More fine in the corridors.
Is there any defects, cracking, etc., that occur in the core wall and slab joints due to axial deformation?
Not the core wall slabs, there are few cases. It can happen. I had experienced there are some effects. That happened in I give the example also. That the Hyatt building, because it's whole the project is still not complete now. It's start the construction in the 2004 and 2015 we went for the mass construction of that one. In that case, we observed that conduits, you can't fix the conduit. That means one side already gone settled. So you have to have a bend the conduit to fix that.
Do you have any experience on top-down construction?
I haven't, but I have observed in that hotel building because I went with one of my friends. So we had done in the Sri Lanka, the Chinese contractor done in the hotel complex.
Town hall.
Town.
Any other questions?
There was a slide which you showed that for the beams, they were building the
Theory.
Yeah. So then doing that, we can just keep the form.
But how in the top? Because that construction is done This one, nah? This one. So from the top, how are you going to cover? If it is rain, you can't, you have to stop the watering. But this is one of the, if it is rain, definitely water will go. But so this is a precaution what we can get it at least. Yeah, this is a fresh crop because this thickness is more than 2.5, 1 meter sections.
Any other questions?
So otherwise you can put the rigiform, but with this reinforcement, it's very difficult to do.
Questions?
That's all.
That's it.
Okay, thank you very much.
Thank you everyone for joining the session. As we mentioned on the chat, the form was opened and it is accessible. So please make sure to fill the form soon as it will be closed in a few minutes. Thank you very much for joining. We will be having another webinar next month. So do keep an eye on the WhatsApp group and check the updates on the WhatsApp group because we will be adding all the details regarding our upcoming courses and events. Thank you very much for joining us today, and we hope you have a lovely day.